Yeah, I did. I have to figure out how many days do they have to keep it in storage before they can dispose of it. So it's got to get down to where there's only 5% left. Okay, the big question is, of those formulas on your piece of paper, which one is it? Okay, is it compound interest? No. If the problem, if it doesn't say compound interest, you cannot use that formula for anything but compound interest. I always have people try to use that formula for other things. You can't. Is this a business situation? No. This is not a business type thing. Is it a nature type thing? Yes. So we are using this formula. Okay. However, last year I gave you these nice, because I usually gave you K. This time I'm not giving you K. Okay. K is the constant of growth or decay. K determines how, Caleb. But you're talking about other things that distract. I don't know, but I'm... Okay, you have not done this one before. In the past, I gave you K. K determines how fast or slow something grows or decays. K is changes. For bacteria, every strain of bacteria, K can be a different number. In this case, we're talking radioactive iodine. K will be a different number than we were talking about some other radioactive substance. So K varies depending on what it is you're studying. You're going to have to find K because I asked you the question is how many days will it take? You can't solve that if you don't know K first. So consequently, you're going to have to solve two problems to get to this answer. You'll have to always find K, then you have to go find what they actually asked you for. Finding K is actually pretty easy if you know the secret. To find K, I have to know some time frame. What is the only time frame I know? I know half-life. I know time is how many days? 60. Okay, but you have to know a starting amount and an ending amount.
100.
They didn't tell us that we have how much we have, period. We don't even have an amount.
We have any amount.
It can be any amount, that's right.
0.
100, and you can go 100, which would mean you're going to end up with 50. You can go with 1, and you're going to end up with a half. You can pick any number you like to start with because you're going to end up with half of it.
2 and 1. 2 and 1. 2 and 1.
10 and 5.
2 and 1.
I'm hearing the 10 and 5's outvoted your 2 and 1, but I don't care. Me, I'd use 2 and 1. But, okay, the point is you're going to have half of it. Now you have to solve for K. It's a log problem. How do I solve for K? Divide by 10. Your choice, we can make that a half. Since you're going to punch it in your calculator, I'd probably just soon make it 0.5 because I think it's easier to type. So I'm now going to be down to E. I'm going to make that 60K. It's a little nicer to read. How do I get K down out of there? I log it. What kind of log? I put natural logs on it, which means I'm going to have the natural log of 0.5 and 60K. And then I have to do what? Divide by 60. And we should get
We just punch that in there,
natural log of 0.5 divided by 60. Okay, K is going to come out to be some horrible long decimal. It won't be a nice number ever. You're going to go with 3 significant digits. What do I mean by significant digits?
You go like
Because this one starts out with a 0.011. Does this 0 count? Is that 3 significant? No. So you need to go 1 more digit. So if you have leading zeros here, those don't count. So go with till you get 3 actual valuable numbers in the, not just in place. Okay, and now, so that's K. Notice when K is negative, you know you're decaying. If you're doing problems with bacteria that are growing, K will come out positive. So if you know it's something decaying, you better have a negative number. Then you go back, and now you try to answer the actual question. Same formula, but now you know what K is. What is it we're trying to find this time? I want how many days will it take? So I need time. So K is going to sit up here as our point 1, 0, whoops, didn't write that right, 0, 1, 1, 6, and time is what we're solving for. Now,
You want to solve for 5% or less.
okay, so yeah, I need to get it down to 5%.
So we do the 100.
It needs to start at 100.
So it needs to start at 100%, but how do you write 100 as a percent?
1.
1. And so you're going to end up with,
0.05.
yeah, thank you, 0.05, get that extra 0 in there to get 5%. So technically, I have to always get rid of the number in front of E, because it's just a 1, so
Yeah, that's easy.
I really don't need to divide 1 over to the other side. But then I can do what to solve it? It's the same thing we just did. You just log it again and solve it the exact same way you did before. It's just that you have to go through 2 steps in order to find K before you do it. Divide it over. And once again, calculator comes out to be rounded off 258.
Our calculator's done.
I don't know, because I just had to it locked the whole system up. So 2 or 3 of you are done, but I don't know how to tell which one you are.
Really bad then on the calculator.
Are you saying the ones that are on the charging dock are the ones that are getting updated, or what?
Yeah. So 258 days.
Can't you have done it once?
You have to pay attention on here to whether it's a capital T or a small t, whether it has a subscript on it or not. So makes a big difference. Anything with a 0 on it always indicates what? Initial value, starting amount. So you're going to have to, that sheet's going to be helpful. These are not particularly hard to work, but you got to get the numbers filled into the formula in the right spot. Okay, so we were actually going to take time, had we had it, to solve the case of the cooling corpse. But I'm going to have to shortcut that a little bit. There's been a murder. The coroner was doing an investigation on a dead body, and then the detective comes back and discovers someone has murdered the coroner. You all know what the coroner is. He's the person, the medical examiner that cuts open the body. Okay.
The detective killed the coroner.
So the detective did not do it. He came back later and found him dead. And so he's got to figure out when did this happen. And so, if you know, with Newton's law of cooling, if you know the air temperature of the surrounding air, and you know the air temperature of the body, you can figure out how long something's been dead.
Yeah.
So this makes you a CSI. Okay, so the actual office had a temperature of 17 degrees Celsius, which they would have to keep it cold, fairly cold, since you're storing dead bodies in there. Okay, so the actual, I need the actual, we're going to have to hold on a second. So here we go. Well, okay, I had that. The coroner's office was set at 17 degrees. The body temperature when he found it was 27 degrees.
We also need to know what the body temperature begins at.
Yes, we do.
98.6 degrees Fahrenheit.
Okay. The temperature of the body at the time is 27. Normal temperature is 37. And we also have to know okay. He found the dead body, then he went asked to investigate. When he came back an hour later, the body temperature was down to 24 degrees.
So what's the rate of it?
So But 1 hour later, after he found the body temp, it had dropped to 24 degrees.
So every hour it drops 3.
Well, but it doesn't drop evenly the same amount. It's an exponential function. So you can't just say every hour it drops 3 degrees. Nice thought, but unfortunately, no, that doesn't work. Okay, so you have to take Newton's law of cooling, and we have to figure out what are we actually looking for. The question is, how long do we think the actual body was, how long ago was he killed? Which would mean I need to find what? I would need to find the time. But in order to find the time, I have to know everything else. Would I know everything else?
You need K first.
I don't know K. So yes, you have to find K and then go answer the question. So we're going to do this twice again. It's not nearly as bad as it looks once you fill the numbers in. Okay, so to find K, I'm going to start in the back here. I have to know a time period. What's the only time period I know from what happened? An hour later. So I know in 1 hour later, so I'm going to do time is 1 hour. I have to fill in all this other stuff that goes up front. So if I'm talking from when he found the body to an hour later when he came back,
Initial would have been 37.
27.
Yeah, the initial was 27.
okay, because the body was originally 20, when he found it, the body started out at 27 degrees. Okay, what's capital T?
Temperature thrown in air.
There, so what's the temperature in the room? 17. Okay, that same 17 goes out front. It goes two places. And then what was the final temperature? 24. It was 24 degrees. Okay, so now clean that up. It makes it a whole lot simpler. So, okay, she said 24 minus 17. Why is she moving 17? Yeah, it's on the outside. It's added. Yeah, we might as well go ahead. We could subtract that 17 over. So that's going to be 7. That's really just 10 e to the k.
You got to plug it.
It's an e. What do you have to do before you can do anything with an e?
For those numbers.
You gotta get rid of the 10 in front every time. You can't have any number in front of e. Which I'm going to just make that 0.7. That's easier. Okay. And then this is at times t is 1 hour. 1 hour. Yeah. That's times. Or if it makes it better, I can do k that way. It's 1 hour. So now how do you solve it? This is not a tough one to solve. Yeah, we just natural log it. We've done these many times. So that becomes the natural log of 7/10 is equal to k. And then we'll cheat here and find out that k is, should it be positive or negative?
Negative.
Yeah, the temperature is, we're going downward. So it is 0.357. A negative 0.357.
And then we just solve it.
And then we go back and do it again. But we have to solve for time this time because we want to know how long has he been dead. So let me write it again. So if we know we're solving for little t this time, we know k. K is our negative 0.357. I need now, from what time period am I trying to solve here?
The whole time he's been dead.
From the whole time he's been dead.
That would have to be 37.
So, okay, what was his initial body temperature then?
37.
Yeah, when he was a live person, his body temperature was 37. Yeah, sorry, I need to fill in T. Did the temperature of the room change?
No.
It's still the 17. Okay, so then what temperature is going to be our final body temperature?
27.
Because it's a matter of, do you want to do it when the detective first found him, or do you want to do it from when he came back an hour later? It really doesn't matter as long as you know which point in time it was.
An hour later.
27.
24.
27, we got it. We'll grab it first.
Just pick one.
227.
17.
Fine, 24. I heard more 24s. It doesn't matter. It'll work either way, as long as you know from which time period you're talking. So you would take off your 17 again, which will leave you 7. 37 minus 17 is now a 20 e to this ugly negative 0.357 t. Okay. then I have to do what? I need to get rid of the 20. So, okay, 7/20, is that going to come down to something nice?
0.5 something. 0.35.
Oh, you guys did make this hard by picking 24. I only know the answers if this is 27.
I have my calculator, we'll work it out.
Okay, well 7/20 is,
0.35.
okay. Because I know the answer when I should have looked. I don't have it worked this way. And then,
Cross off the E.
yeah, natural log it. Now you're beginning to see a pattern to working these. And so, which is why we tend to prefer the word problems over everything else. Because then if you last but not least divide it by negative 3.57,
It's 2.94.
2.94.
About 3 hours.
So, yeah. So 2.94 hours. You would have actually known then if we had looked at this whole thing. He came back. What time did he say he come back?
Came back an hour later, didn't it?
Yeah, they actually told you. Oh, okay. The agent, when he discovered him, when he first found the body, it was 5:05. So we went with the 24. So that means that was at an hour later. So that was at 6:05 in the evening. So if we now know the body was dead 2.94 hours, you could change 0.94 into minutes. How?
By times it by 60.
Divide times by 60. 0.94 times 60, would you? Probably very, I should know that. Actually 56. So you'd have to take away 2 hours and 56 minutes to figure out.
Where'd you get 2 hours and 6 now?
No, that is
94.
2 hours, 0.94 is 56 minutes. So from 6:05, you'd have to go back 2 hours and 56 minutes, and you would have an approximate time of death.
Yeah.
But we did 24, so don't you have to add it up?
No.
I already did. The original time was 5:05, so I made it 6:05.
Isn't it 309?
Yes, that would be 3:09. So around 3:09 p.m. And then if I actually had time to give you the whole problem, they give you this whole list of people who checked in and out of the building, and so you can go looking through the list trying to figure out who was in the building at that time of day.
Find out who
And find out who the killer was. Which actually, it turns out, no one was in the building at that 3:09, except the security guard who was checking people in and out. Because it turns out there's no one on this list that hits that right time.
So the security guard killed him?
So the security guard did it.